All right, let's get this started. Before I get into your questions from midterm review number 3, 1 through 11 odd, are we all good on supplies to bring? I went over yesterday in class, supplies to bring. We don't need to clear the calculator, do we? We okay on that? All right, if you need refresh on clearing the calculator, let me know. I just don't want to stop. Again, I got 70 students in Gym A on Monday, so I don't want to stop and wait for everyone to, hey, how do I clear my calculator? Everyone's all right on the setup? Everything is in pen, all right, unless you're doing a construction or a graph. And just let me give you a little example because I always get this question at the midterm. Let's just say you're doing a coordinate geometry proof. The graph of it can be done in pencil, but all your work, like distance, midpoint, slope, has to be in pen. Okay, so only the actual graph should be in pencil. All right. Any questions about the setup? Remember, you can't stay past 3, so manage your time wisely. All right. All right, midterm review number 3 now. 1 through 11 odd. Anything we want to go over? Anything we 1 through 11 odd? Anything we want to go over now that we've seen the answers? Luke, start us off. Okay. 1 and 7. I got them. 1 and 7. Got it. Okay, so everyone take a look at number 1. Got it right, got it wrong. Okay, which one of the following lines are not parallel to each other? So I'm looking, well, first of all, let's talk about is parallel. What do I know about the slopes of 2 parallel lines? They are equal to each other. So I am looking for the choice where the 2 lines, their slopes are not equal to each other. So if I take this first one up here, what's the slope of the first line in number 1? -3. Now here, you got to do a little work to find what the slope is. What do I need to do on both sides to find the slope? Divide by 2. And when you divide -6 by 2, you end up with -3 minus 4. So what's the slope of this line? Okay, so they both slopes are equal. So those lines are parallel. I'm looking for the ones that are not parallel. So let's keep this show rolling. Let's go to number 2. Oh, look at number 2. Yikes. 4x minus 2y equals -10. What do you want to do first here? Okay, how? That's what my question is. How do I get y by itself here? Move what over first? Everyone all right? I'm just trying to get y by itself. So I don't know what the slope of this line is unless I get it into y equals. So I'm going to move the 4x over by subtracting. So -2x equals -4x minus 10. Divided both sides by -2. What do I end up with? 2x plus 5. What's the slope of this line? 2. Just 2. Just 2. All right, let me take 7y minus 14x equals 12. What do you want to move over first? The 14x, and then when you divide it by 7, what's the slope? 2 as well. So these came out to be the same. Choice 4 was the answer, correct? Okay, so let's go over that one then. So -y equals 5x plus 3. What do you guys have to do here to get y by itself? Because it's not. Divide by -1, and we end up with -5x plus 3. What's the slope of that line? -5. All right, so let me go to this one right here. 2y equals 10x minus 8. What do I have to do on both sides here? Divide by 2, and what's the slope come out to be here? 5, but it was -5 here, so those are 2 different slopes. All right. And we said 7 was the other one? Hugh? Which statements could be proved to use triangle? All right, so it looks like I got a little diagram I'm going to have to draw and check. Well, I can tell you which one I'm going to get rid of right away. without even drawing a diagram. Why? Angle, 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 never a way to prove triangles congruent, right? Sorry. It's a way to prove similar, but not. All right, so let me take a look at all of them right now. And I'm only going to mark up one diagram. So AB, BC, angle A. Is that a method to prove triangles congruent? Nope. I know we joke all the time, but I still have people write down, you know, the old side-side angle. Nope. All right, so that's gone. That's not a way. All right, here we go. AB, angle A, and angle C. Method? Angle, angle, side, right? So that is a method. And then let's just talk about, I think it's the 4 should be the same thing, right? 4 is probably side-side angle again. Let's see, angle A, AC, and BC. Yeah, side-side angle again. So just choice 2. Anything else you want to look at, 1 through 11? How are we feeling here? How's the preparation going? I feel good when you're in class and I see people after school, but I don't know, other than that, what else is going on? We feeling all right? Hi, Emma. 2? Well, I'll get to, yeah, that's part of class today because we had the odds last night. Settle down. Anything else? Okay, well, let's go to number 2 then, because I was going to go over a couple of the even ones today. All right, here we go. Let's help Emma out here. 1 and 2 form a linear pair, meaning linear pairs are supplementary, right? So angle 1 plus angle 2 equals 180, right? So if I'm just drawing a linear pair here, all right, what do I know? Angle 1 is 24 more than twice angle 2. I have no idea about angle 2, so I'm just going to call it x. Anybody help me write 24 more than twice that? Sean? 2x plus 24. 24 more than twice angle 2. And again, what do I know about linear pairs? They are supplementary, so I'm going to say 2x plus 24 plus x equals $180. You just got to be careful here, because I'm going to say when I solve for x, that answer's up there, I bet. 3x plus 24 equals 180. 3x equals, what do we got there? 1 something 6, 56. Look good? All right, x is going to be equal to what, 52? And yeah, of course, it's up there. They want you to pick it. Which one's the bigger one, angle 1 or angle 2? Angle 1 is 24 more than twice angle 2, and I'm looking for angle 1. This is angle 2 that we found, 52. So what do I have to do to find angle 1? Or, okay. Or I could plug it in, Will. Yeah, either one. Both of them, yep. Either way, it'll get me what? 128. Yep, just watch out for that. We okay there, Emma? Here's your question. Just asking if everything's all right. Hey, where do the medians intersect? Yeah, hey. Whoa, whoa, whoa. In center. Orthocenter. Circumcenter. And eventually, I would, if you haven't done so already, say to yourself, can I construct these median, perpendicular bisector, altitudes, angle bisector, and then could I construct the point of concurrency from it? Woo! Were there others that you, anything, because I want to go over the proof at the end. Anything else here? Okay, and I'm going to start hearing from you guys as well, instead of me just throwing up all the answers. So if you go to number 12 real quick, set it up if you haven't done so already. I discussed yesterday the big 4 cluster of proofs that we've discussed this year. Okay. And there's 3 proofs on the midterm, so Okay. Got to prove the two outside ones congruent. The only piece of information that would help you proving them congruent is I gave you a pair of sides in AC and CD. So I'm going to ask you, I'm going to go around the room here. I'm going to find out if you guys can find me another pair of sides or angles. All right. Any theorem you have in your tool belt there. All right. So I gave you a pair of sides. You guys are on the hook for the other 2/3. Anything you see here? 16, anything you see that I could use? It's okay. Just if you see something, let us know. Okay, I'll just stop right there and see if anybody knows where you're going with that. EB congruent to itself. Yep. Reflexive. All right, you can take Maggie's lead or you can go another direction if you want. That's what's good about proofs. 12. Okay, so you're going to take BA and subtract what from it there, Emma? EB, and you're going to say that's the same length as ED minus EB. Yep, little thing we like to call subtraction. All right. Again, you could go a different way right now or keep on with Maggie and Emma's path. It's up to you. 16. AE congruent to BD. Yep, substitution. So now you guys, thank you very much. I don't know how to spell substitution. Okay, we got a pair of sides now. Another pair of sides. 1, 2, 3, 1, 2, 3. All right, need one more pair of something here. Come on. I know it's a little bit difficult to find than the sides. 5.
Triangle ACB is isosceles.
It is. I won't write that down, but it is.
Oh, you don't have to write that down?
No.
Well, I did.
Okay.
Angle
Mike, everyone. Isosceles. Mike.
Yeah.
All right, where are you going with that, Mike?
Angle A is equal to angle B.
Yep.
Because opposite or congruent angles are cross triangles.
In a triangle. Make sure we got that part there, everyone. In a triangle, congruent angles are across from congruent sides. And now, what method can I say the two triangles are congruent? Got a method for me to finish this proof? 18, got a method? There you go. Side, angle, side. All right, not bad. How do we feel about that one? Not bad. Anything on this proof? There was another one I wanted to do with you that I thought was a little, definitely not that one. 6. It gave me coordinates, so I graphed it. You will have scrap sheet of graph paper on your test that you can utilize anytime you want. All right, so I wanted to see what the triangle looked like. And good thing I did because I could eliminate definitely one of these right away. I don't think any of them are right angles, especially ACB. All right, so now comes the question, how do you, wait, you didn't say I needed to bring a protractor, so how am I going to know angle A is congruent to angle B or angle ABC equals 60? Well, we have a theorem that says if angle A is congruent to B, what else should be congruent? The sides across from them, correct? All right, so if this is true, I would know that BC is congruent to AC. How could I figure out if they're congruent or not? Using distance, okay? So that could be choice 1 and 2. Anybody know why it would come out to be choice 4 if it was choice 4? If angle ABC was 60. Anybody know what type of triangle all the angles come out to be 60? Equilateral, which means what about the sides? So if all three sides came out to be equal, I could say angle ABC is 60. Okay? Right? I think you guys know it's probably not that one, but here we go. So let's use distance. I just want to do this problem to review the distance formula again, or Pythag, whatever you prefer to use. So x2 minus x1 squared, y2 minus y1 squared. I may have asked this already this week, but is that formula going to be given to you? Nope. Midpoint won't, slope won't. What do you want to find the distance of first? AC, sure. Okay, distance AC is going to be, let's see, 6 plus 1 squared for the x's, and for the y's, I got 0 plus 2 squared. So I have 49 plus 4, which is the square root of 53. I just used the coordinates. All right, let's hope BC matches it, right? So the distance of BC. Well, the x coordinates help me now. I'll turn it over to you guys. X coordinates for B and C. So I can go 6 plus 1 there. And then what about the y coordinates for B and C? Y coordinates, 2n, 0. So I can go 2 minus 0 here. Oh, looks I might be on the right track here, huh? 7 squared plus 49 and 4 again. Square root of 53. So these two sides were congruent, meaning what about the angles? Angle A and B and angle B must be congruent. Yep. And we can check real quick to see if it's equilateral or not. Do I need to use distance formula on AB? Why not? Oh, count. 1, 2, 3, 4. I don't think 4 is the same as the square root of 53. So. All right. Guys, have you thought about any topics you want me to go over? Forget about the questions in here. Are there any topics you're like, oh, and I mean like more specific topics. Don't say, hey, quadrilaterals. Okay, I'll go Maggie, and then I'll go Will, and then we'll go to Amy here. Go ahead. Everyone's anti-proof in here. Yes, indirect proofs. I believe I gave you guys one. If we could do that one. Emma, where are we going? Midterm 4, number 12, the anti-proof. Okay, here we go. For very first thing, if we do have you do this proof on Monday, it won't say do it indirectly. How are you going to know, though, as you read through the proof, oh, I have to do it this way? Amy? In the proof statement, it's going to say proof something's not happening. Automatic, okay, I got to do this indirectly. First step you're given. Second step is what we called our assumption. Where did you get your assumption from? This is what I worry about. No. It's the opposite of the proof statement. Has nothing to do with the given. It's the opposite of the proof statement. So what's the opposite of my proof statement here? JP bisects angle HJK. And you can treat that as a given now. Use it. All right, use it as a given. Before I start the proof, hold on, before I start the proof now, What is your goal of an indirect proof? Contradict a yes, that's where the given comes in. Contradict a given. Well, I have two of them here. Which one's going to be easier to contradict? P is not the midpoint of HK. How do you contradict that? By saying P is the midpoint. So we need to figure out how we can get P to be the midpoint. How can we do that? By showing which two line segments are equal. Okay, there's our goal right now. Let's prove HP congruent to PK. Probably going to have to do that. What are we going to have to do first before we get to HP and PK being congruent? Yeah, let's get the triangles congruent. Again, use your assumption. Use your assumption. HJ is congruent to JK. Okay, I got that. That's done. All right, I'm going to leave it up to you guys now. What's some other things in that triangle you can give me? 10?
So you can do that angle PJH.
Yep.
Congruent to KJP.
Yep, you use your assumption right there. Perfect. So angle HJP congruent to angle KJP. Definition of a bisector. That's using your assumption. Yeah. All right, and there should be one other thing I can use here that'll make the triangles congruent. 14, what else can I use? Oh, took a detour on me. I didn't think anybody was going to say that. But go ahead, you're correct. Right, the big one's isosceles. So heaven saying H and K are congruent. Anybody going to do the reflexive? Because you can do that too. Go ahead. We're just going to have a different way of proving the triangles congruent. So angle H congruent to angle K in a triangle. Congruent angles are across congruent sides. Okay, we're getting there. We're getting there. All right, now prove your triangles congruent by whatever method if you use reflexive, it'll be side angle side. If you use the angles like I did, it'll be angle side angle. Triangle HJP is now congruent to triangle KJP. Now what do I know about HP and PK? Cameron, you got a question?
Yeah, so in the assumption,
Yep.
you always have to use that as a given.
Yeah.
Later in the proof.
Yeah, it will be.
So, okay.
Because if you didn't use it there, and let's just say you did reflexive and those angles, that angle isn't in between. There's no side-side angle. You needed those bisected angles. All right. All right, now what do we know about HP and PK? They're congruent by a little thing we like to call CP-CTC. Now what do I know about point P? It's a midpoint. I'll help you out with the reason here. Some of you may know it, though. Not definition of a midpoint. P is the midpoint of HK. What would be, how do you know? Yeah, because you just proved what? HP congruent to PK, so it's got to be a midpoint. And now what do I have here in my givens and this statement 7? I have a contradiction. That must have been, my assumption must have been false. So if my assumption's false, what's true? JP does not bisect. So once I have that contradiction, I can prove what was asked. JP does not bisect HJK. You guys remember at the last step here? Assumption led to, yep.
On the final, if you give us one of these, do we have to,
Midterm?
Yeah, the midterm, if we don't say the steps that led to one.
Yes. That's what we practice. What are the steps here? 1 and 7. Amy, go ahead.
I'm confused on how that works because the proof statement, it says JP does not bisect angle HJK. So
Yep.
how does that?
Okay, here's what we did. We assumed this was true. Okay? By assuming that was true, that led us to the fact that P is the midpoint. But that can't be true because what was I given? That it's not the midpoint. So this led me to a false statement, which means this cannot be true. If this isn't true, that must mean the opposite is. Sure? Okay? Your assumption led to an incorrect statement. So your assumption's not true. The opposite has to be true. Okay, Will, you had a question.
Proofs or not?
Wait, is it steps 1 and 7?
Yeah, why?
I thought it was step 2 and 7.
No. Your contradiction is it's not a midpoint. It is a midpoint. That's my contradiction. Right? That's what I contradict. I contradicted this statement right here.
So it's always going to be the first step.
Well, it depends if you put your givens in the first step. You can put your assumption in the first step too. You want to get back to me here? I'll go to Amy.
Just proofs using kites.
Don't have to worry about proofs using kites. You will have to worry about algebra maybe using kites. Do you want to go over the kite properties? Yes. Okay. Kite properties. Yes, Luke.
I just have a question about this.
Go ahead before we go on.
The steps in on the midterm, or will we be fine without?
No, I want you to write the contradicted steps in there. Okay. Am I bringing what? Steps? Oh, am I grading yours? Yes. The regents, no, I am not allowed to grade yours, but the midterm, yeah, that's fine. It's a school midterm, so I'll be grading them. All right, here we go with the old kite. Let's see if I can do this. Oh, we stopped working. Good. Let's try this again. Might have to go old school and draw on the board. Nope, good. Okay, here we go. I don't think that's not going to fly. I might have to pull up a. All right, give me a second. I just got to pull up a picture of a kite. And how did I know it was going to give me that? Okay, here you go. Let's go over our properties. First property, usually it's already labeled for you, but it's got two pairs of adjacent sides that are congruent and no pair of opposite sides congruent. That's why it's not a parallelogram. We call it a kite. It has one pair of congruent angles. Where are those pair of congruent angles located? They're the angles formed by the non-congruent sides. All right, so let me put PQRS. Let me label. So if it's the two angles formed by the non-congruent sides, what two angles are congruent up here? P and R. Good job. All right, P and R. All four angles add up to 360 because it's a quadrilateral. Just not because it's a kite, because it's a quadrilateral. All right, now we start getting a little nuts when I put in the diagonals. Anybody remember about the diagonals? Perpendicular to each other. That's the first main one. Yep. So that forms a what here? A right angle, yep. Right triangle, maybe, you know, start thinking Pythag. And also I heard somebody say it, the longer one bisects the shorter one. So cuts the shorter one into 2 equal parts. But the longer one does not get bisected. Okay, so those are the four main properties of a kite right there. Good, Amy? Anything? Will, okay, going back. Here we go. This should be good.
So proving a parallelogram is a rhombus.
Okay. So you want me to start out with a parallelogram?
Yeah, that proves a rhombus.
Okay, so this is a parallelogram already. How do I make it into a rhombus? Couple different ways. A parallelogram with there's a rhombus right there. A parallelogram with 2 consecutive sides. There's other ways. Actually, I'm not going to. Let me do it this way. A parallelogram with anybody? Rectangle.
Oh, they have right as
Perpendicular diagonal. Yes. And there's one other way, not commonly used, but it's also a property, so it's good to go over. If it's already a parallelogram and one of the diagonals bisects the angles it's drawn to, yes. So congruent, congruent. Yep. So those are 3 ways to get a parallelogram to be a rhombus. Good questions. Any other topics? Think about them because tomorrow's our last day as a class if you're not coming to the review session. So think about it. Anything else, or you just want to have it? Midterm 3? This one?
Yeah.
Okay. Midterm review number 4, question 8. Good questions here, guys, today. Keep them coming tomorrow. Okay, partitions it into a ratio of 1 to 2, which means you're going to cut that line segment into how many congruent parts? 3 congruent parts. All right, so let me start with the x coordinates of A and B. It goes from -2 to 7. That's a total of 9 units. And you have to divide, you said divide it up evenly, 3 equal parts, right? So I'm going to take that 9 units, divide it up into 3 equal parts, and that'll give me 3 units every time. But I need the point that's 1 to 2. So I'm only going to have to go 3 units. Because here you go, here's what it's going to look like. I'll graph it at the end, but here's 3 equal parts, right? Where's the point that breaks it up into 1 to 2? That point right there. So that's why I'm only going to go 3 units. I don't need to go any more than 3 units because I'm trying to get to that point right there. Okay? So where did I go from -2? I'm going to go 3 units to the right. And where do I end up on the x-axis? At 1. Do the same thing now, but for your y coordinate. Where am I going on the y? 4 to negative 2? Ooh, all right, a little tricky on that one. What are you doing here? 4 to negative 2. Going down 6, right? So down 6. So I take negative 6 and divide it by 3. That means I'm going down 2. How many times do I go down 2? Remember, I'm just trying to get to that first point. So just once. Hey, it's whatever, remember, it's whatever number's here to the left first. If that's a 5, I'm going to multiply by 5. If that's a 10, I'll multiply by 10. But since it's a 1, I'm only going to do it times 1. So now, where did we start again? At 4? So 4, go down 2. What coordinate do you end up at? 2. So what's my point of partition here? 1, 2, and I provided a graph. I would just go back and see graph A and B and make sure what? 1, 2 is on that darn line, because if it's not, something went wrong. Go back and check your work, because it should be on the line. What do I have tonight there, Sean? What do I have going on tonight?
Midterm review number 4, 1 through 9.
Okay. Any questions? All right. You guys can get going on 1 through 9 if you want. Try out problems you haven't done. Midterm 1, 2, and 3 are all posted on Aspen. Okay. Reviews 1, 2, and 3. The answers are all posted on Aspen now.